Hello everyone, welcome to the class. So in 10th standard science part 1 we have been discussing chapter 2 periodic classification of elements. So we have already discussed the first section of this chapter. Now we are going to the second video of this second chapter. So the modern periodic table or the long form of periodic table. So the other name of the modern periodic table is long form of the periodic table. So in the modern periodic table, elements are arranged in accordance with their increasing atomic number. So we have seen that in modern periodic table, elements are arranged according to increasing atomic number. Before that, the elements were arranged in a periodic table according to increasing atomic mass. But in modern periodic table, elements are arranged according to the increasing atomic number. The properties of elements can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic number. So the properties of elements we can predict accurately with the help of modern periodic table, since it is based on atomic number. Modern periodic table is also called the long form of the periodic table. And most of the drawbacks of Mendeleev's periodic table appear to be removed in the modern periodic table. And the position of hydrogen is also, the ambiguity means there was no proper position to hydrogen in the modern periodic table, that was also solved. So now we are going to discuss the structure of the modern periodic table. The modern periodic table contains 7 horizontal rows. You can see the 7 horizontal rows. 1, 2, 3, 4, 5, 6, 7. So it has 7 horizontal rows called periods 1 to 7. Similarly, there are 18 vertical columns in this table and are called groups from 1 to 18. So a modern periodic table has 7 horizontal rows called periods and 18 vertical columns. You can see vertical column 1, so it is called the group 1. Group 2, group 3, likewise 18, you can see group 18. So this is the group 18. So 18 groups are there and 7 periods. This way counting, horizontally 7 periods and vertically 18 columns or groups are there. 7 periods, so you have to remember that a modern periodic table have 7 periods and 18 groups. The atomic number are serially indicated in the upper part of the boxes. So each element is placed inside a box, and each box, you can see several boxes in the table. So each box represent a element in the periodic table, and in this table the atomic number is represented in the upper part of the box. You can see atomic number 1, 3, 4, 11, 12, you can see likewise. So 1, then 2 is here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Likewise this way it is going. It is going in horizontal ways. So you can see in each of this box upper part the atomic number is written of each of the elements. Apart from the 7 rows and 7 rows, you can only see 7 rows or 7 periods in a modern periodic table, and apart from that there are also other 2 separate periods in the periods or vertical rows in the bottom of the periodic table, and they are called the lanthanide series and the actinide series. You can see it here. So these separate horizontal rows are or periods which are given separately from this periodic table. They are lanthanide groups and actinide groups. So apart from the 7 periods, there are also 2 other periods in the modern periodic table which are called the lanthanide and actinide. So, and there are 118 places for elements in the modern periodic table, and the entire periodic table is divided into 4 blocks: S block, P block, D block and F block. So there are total 118 elements in the periodic table, and 4 blocks: S block, P block, D block and F block. You can see the S block here, S block elements, P block elements. So this much part consists of the P block, and this much the first two groups S block, and from 13 to 18 is the P block, and from group 3 to 12, group 3, you can see that group 3 to group 12 is the D block elements, and the lactonide last two periods are the F block elements. The F block contain group 1 to 2. You can see group 1 to 2 is the F block, and 13 to 14, group 13 to group 18 is the P block elements, and group 3 to 12 is the D block, and F block is the two periods, last two periods is the F block elements, and they are called the transition elements. So the F block elements are also called the lanthanides, and actinides are the constituents of F block. They are called the transition elements. And you can see the D block elements are transition element. A zigzag line can be drawn in the P block element of the P block of the periodic table. You can see a zigzag, you can see like this way it is going. A zigzag is marked in the P block of the periodic table. So for what purpose it is shown like that? The metalloid elements lie along the border of the zigzag line. So the zigzag lines border the metalloid elements are there, and all the metals lie on the left side of the zigzag line, and all the non-metals on the right side of the zigzag lines. So on the border means on this part constitute the metalloids. So in the border of means this much part, this much elements will be metalloid, and the left side means this side constitute the metals, and this side constitute all the non-metals. So in P block it is a zigzag separation is shown. So on the border of the zigzag is the metalloids, and left side you can see that left side of the zigzag lines is all metals, and right side of the zigzag, left side is all metals and right side is all non-metals. So here we are going to see the electronic configuration or the shells in an atom, inside an atom. So there are the shells, name of shells are, the first shell is K shell, L shell, M shell and N shell, and the number of elements in K shell. So the first shell is K shell is the first shell. So the total number of elements in the K shell can be found out by using this formula 2n square. So in the place of n we will substitute the value 2. When we substitute 2 in 2n, so it will be 2 into 1 square, that is the total electron capacity, that is the K shell can constitute a total of only 2 electron. K shell can constitute maximum of 2 electron, and the next second shell is the L shell. So it is since it is a second shell, where the total number of electron can be found by putting in the place substituting in the place of n we will put 2. So it will be 2 into 2 square, that is 8. So 8 is the total number of electron in the second shell. The third shell is M shell. So here 2 into 3 square, n is 3, so 2 into 3 square it is 18. So the total number of electrons in the M shell is 18, and same way N shell 2 into 4 square, since n is equal to 4, so it is 32. So these are the electron capacity of each of the electron shells. So K, L, M, N are the electron shells. The characteristics of groups and periods in a periodic table are understood by comparison of the properties of the elements. So the elements in certain groups or periods have certain similar characters. So this can be understood by comparing their properties. And various elements of all the elements in a group show similarity and gradation. So in a group all the elements will show a various properties, similarity and also gradation. Gradation means their increase in the number of shells or electrons, and the properties of elements change slowly while going from one end to the other in a particular group. So in a particular group, when you can take the first group. So this is the first group, we will take so when taking a particular group, the elements show similarity in their property, but when we take a particular period, if we take this period, that is period 4, we take the elements show differences in their properties. Within a period, the neighboring elements differ slightly in their properties. So inside a period, when the closer elements or neighboring elements which are too close to the element, they will have only slight difference in their properties, while distant elements, means which are at great distance, differ widely in the properties. So it means that when the elements are close, they will have only slight differences, but the elements are at far distances, they have great difference in their property. Elements in the same group show similarity and gradation in their property. Means an element in same group shows similar property, and the characters of groups and periods in the modern periodic table are because of the electronic configuration of the elements. So the characters means the similarities in the properties of elements in the groups and periods are because of their electronic configuration. It is the electronic configuration of an element which decides the group and period in which it is to be placed. So the electronic configuration means the you have seen how we will write the configuration, that is the number of elements in the first shell, K shell, L shell, M shell, N shell, etc. So that decide where, in which group and in which period the element is to be placed. If we look at elements from any group, you will find that the number of their valency electron is the same to their electron configuration. So we are taking the example of group 2. The first element is beryllium. Its number is 4, atomic number is 4, and magnesium, its atomic number is 12. So we are going to write the configuration of beryllium. So the atomic number is 4, so the first shell contains 2 elements, and what remains? 2 elements remain. So 2 is the configuration. So the number of electrons in the last shell is 2. Next is magnesium. Magnesium is the next element. You can see in this group, second group, magnesium, and its atomic number is 12. So its configuration will be 2. The next shell, 8 elements. What remains? 12 is the atomic number. So 2, 8, and another 2 electrons remain. So 2, 8, 2 is the configuration of the magnesium, and 2 is the outermost shell, number of electron is 2. So you can see inside a group, number of electrons in the outermost shell, the last shell is same. You can see I took the group 2, their outermost shell number of electron is 2, and also their group number is also 2. While going from top to bottom within any group, one electronic shell gets added at a time. So when we go from top to bottom at any group, you can see here the example of this is the second group. So in the first group, first element is beryllium. So here 2 shells are there. Next is magnesium. Here 3 shells are there. So 1, 2, 3. So 1 shell is added. When next is calcium. So calcium, it will be 4 shells. So 1 shell is added when we go from top to bottom in a group. So this is a group. So in this group, when we go from one like this way, we go, 1 shell is added to the shell, means you can see the configuration. 1 shell is added to the each of the element when starting from top to bottom. Uranium has atomic number 92. All the elements beyond uranium are man-made. That is from 93 to 118. That is from 93 to 118, all elements are man-made. So the uranium is a radioactive element, and its atom after uranium, beyond uranium, all the elements are radioactive. So in the modern periodic table, electrons are filled in the same shell while going along a period from left to right. So in a period, So these are the horizontal rows are called periods. So in a period, when we go from left to right, the electrons are filled in the same shell, means there is no increase in the number of shells like we have seen in the group. In group, from top to bottom, the number of shell increases by 1. But in period, in a period, you can see in a period there is no increase in the number of shells. Electrons are filled in the same number of shells, but at the beginning of the next period, a new electron shell starts filling up. So inside a period, the number of shells is same, but when it goes to the next period, the number of shells increases. That is, here there is more number, one extra shell when going from this period to this period. That is, from first to second period there is 2 number of shell. That is, there are 2 shells, and in the third period there will be 3 shells. In the fourth period there will be 4 shells. So likewise, a increase is there when it goes from one period to other, but inside a period from left to right there is no increase in the number of shells, and also inside a group there is increase in the number of shells. The chemical reactivity of an element is determined by the number of valence electrons in it. Valence electrons means the number of element in the last shell is called valence electron. So the chemical reactivity of an element is determined by the valence electron and shell number of the valence shell. As per the electron holding capacity of shell, 2 elements are present in the first period. So in the first period there are 2 elements in the first period and 8 elements in the second period. You can see that there are only 2 hydrogen and helium. Only 2 elements are in the first period, and in the second period there is 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So 8 elements are in the second period, and also 8 elements in the third period, and in fourth period there is more number of elements. The third period also contains 8 elements due to the law of electron octant. When the properties of element in a period or a group of the modern periodic table are compared, certain regularities observed in their variation. It is called a periodic trend. So also likewise in the previous periodic tables, in the modern periodic table also there are certain regularity, means similarities in the properties of elements in a period or group when observed their variation. So these regularities observed in elements, properties of elements in a period or group is called periodic trends in the modern periodic table. Periodic trends means in a period a regularity, similarity is repeated. So periodic trends are present in the modern periodic table. Next is an important term, valency. So what is a valency of an element? So the number of electrons present in the outermost shell of its atom of an element is called its valency. So valency is very important. Based on the valency we decide where to place an element in a periodic table, and the chemical reactivity of an element everything is based on the valency. So valency means the number of electrons present in the last shell, outermost shell of an atom, means the atom of the element.